All right, so welcome to class here. This is Pre-Calculus 20. We're using Pre-Calculus 11 textbook, McGraw-Hill, Ryerson. So these are where the clips are from. You have that textbook in front of you. I will ask all of you to go to 2.2 now if you want. Just don't be working on anything other than this right now. So 2.2, and this is a bit of a, this is all new stuff to you probably. But this one, I'm not sure if you've done this before. This would be something brand new. So you'll have to pay attention. We're talking about trigonometric ratios, like we have been this chapter. And we're talking about how do we find the trigonometric ratios, that would be sine, cos, and tan, for any angle, given a point that's on the terminal arm of the angle. So I'll show you what I mean here. And these are the focus points here that I won't read over, but we'll be talking about this today. So let's say we have something like this, and this is in your textbook. And I have a point right here, the point 3, x value of 3, y value of 4. This is the point right here, okay? 3, 4. And what I'm saying and what I'm teaching you today is that we can find out what the trig ratios are for this angle theta that is made by taking the terminal arm and swinging it up so that it passes through the point 3, 4. And we could do any point. We could do 6, 1, and this would be the angle, right here. That would be theta. We could do 1, 5, and this would be the angle right here. You see that? So we could take any point and we could swing it around way over here, this point right here, and that would be, the angle that's made by this line. You see? So we can figure out, if we're given a point on the coordinate plane, the terminal arm of the angle passes through that point, we can find out what the trig ratios are for the angle that's made. Okay? Now you're thinking, wow, that's going to help me in real life. Well, again, not all of this math is directly related to you making money on your paper route or working at Safeway or whatever. It's not directly related to what you're doing right now in your life, maybe. But this is foundational stuff for understanding higher level math. So if you can understand sort of, what trig ratios are, understand, how we can find trig ratios, understand how angles work, understand, right triangles and stuff like that. This is a basis. It's like a foundation for higher level math. Every house has a foundation. And I can tell you that it's not a lot of fun building a foundation. I did that for a summer. I did concrete work for a summer. When I'm not teaching, I did concrete work. Not a lot of fun, a lot of hard work, and we were building foundations for basements. We made sidewalks. We did all sorts of cement stuff. And it's not a whole lot of fun, but it's really important, right? The foundation for the house, super important. So this is sort of foundational stuff, okay? Now, here's a couple things. We have, and we know, the length of this side of this right triangle. See the right triangle that's formed here? Okay? There's a right triangle that's formed by this terminal arm of the angle and the x-axis. So there's an x coordinate right here. There's also a y right here. The x is 3 units, the y is 4 units. So we actually have a triangle. Oh boy, that was a bad line. Let me try that again. So we actually have a triangle, a right triangle, and this is just the same triangle kind of blown up. Here's the angle. This is 3, this is 4, and this is r. We're going to call this r, okay? We're going to call this r. It's like the hypotenuse of the right triangle, but it's r. So this is x, this is y, this is r. Okay. With a right triangle, we could find out what r is. Okay? And why would we want to know what r is? Because for this angle right here, how many of you remember SOHCAHTOA? Do you remember that? SOHCAHTOA. All of you should have heard that before, and that's just a way to help us remember how we find the ratios for the trigonometric functions of sine, that's what the S stands for, cosine, the C, and tangent. So in a right triangle, for any given angle, such as this, theta right here, we find the sine of theta by taking the opposite side and dividing it by the length of the hypotenuse. Well, this is the hypotenuse. This is the opposite side. So we can find the trig ratios, but we do need to know what r is. So how are we going to find out what r is? A right triangle, we're given 2 sides. How do we find the third side of a right triangle, given the other 2? What's the theorem called, or who's the guy? Pythagoras, right. Pythagoras' theorem, good. So that's going to be a squared plus b squared equals c squared. So a would be maybe 3, b would be maybe the 4 then, and then the c is really r. So pop down here, that's going to be 9 plus 16 equals r squared. 25 equals r squared. 5 is r. So r equals 5. Now we have the three sides of the triangle, and for this angle now, I can use SOHCAHTOA to find sine, cosine, and tangent for this angle. Okay? Now, SOHCAHTOA actually turns into, if we let this equal x, and this equal y, and this equal r, SOHCAHTOA actually turns into, are you ready for it? Circoxertix. Circoxertix. So that's an easy way to remember that. SOHCAHTOA is equally as dumb as Circoxertix. Okay? But that's how you can remember it. Circoxertix. And of course it replaces the opposite side. Look at this angle. The opposite side is actually y. So SOH becomes SYR. You see that? SYR. And cosine is not adjacent over hypotenuse, it's actually x over r. And tangent is y over x. That's opposite over adjacent. So the opposite, adjacent, and hypotenuse is replaced with y, x, and r. Okay? You can still think SOHCAHTOA if you want. Doesn't matter. But it's going to be a little bit tougher when you have an angle like this, right? And then, okay, what's the opposite side of a triangle made by this? Well, this is where we're going to have to get into reference angles. And the reference angle is still going to be related to this larger angle, of course. And then you've got opposite, you've got adjacent, you've got hypotenuse. That's x, y, r. Okay? Okay, so let's just go down. This is also in your textbook. So this is a bit of a summary here. All right? So if you have an angle, theta, and you know the point x, y, you can solve for r. That's what you want to do first. And that is using Pythagoras' theorem. So r would be the hypotenuse. It's the square root of the sum of x squared plus y squared. Okay, so that's how you solve for r. When you have that, the angle, the trig functions for this angle are given by s, the sine, is the y value over the r value. The cosine is x over r, and the tangent is y over x. That is Circoxertix. Okay? All right? Now, any questions so far? Okay, let's go back up here real quick. So the sine of this angle, first of all, what does this angle look like? What's your guess for the measure? What would be the measure of this angle theta? What's a guess? 60. Okay, that's not a bad guess. We're going over 3 and we're going up a little bit more than 3. So 45 would be where we go over 3 and up 3, right? So this would be 45. Saying it's a bit more than 45, could be 60 maybe. Okay, so it could be close to 60. Well, the sine and cosine and tangent, we can find the sine of theta equals, what is it? Y over r. That's 4 over 5. The cosine of this theta is x over r. And the tangent of this theta is y over x. That is 4 over 3. Okay? All right, so do you know how? This is very important now. You guys need to know this, and I'm wondering, because there's usually a little bit of trouble with this, but how do you find the exact angle now given the trig functions? Who remembers how to do that? Anybody remember how to do that? Sorry? Okay, sin minus 1. Okay. Yes and no. Okay, it's sine, not sin. We'll call it sine. And the minus 1 is not subtracting 1, it's to the negative 1. So sine to the negative 1, yes, or inverse sine. There's also a special name for it. Arc sine. Have you ever heard of that before? Ooh. That's what we'll call it in calculus, okay? You just beware. It's going to be awesome. So sine to the negative 1 is what it is, you bet. So sine to the negative 1 of 4 over 5 is going to equal theta. So let's see if it's 60. You thought it might be 60. Let's see. Let's see. So second function sine of 4 over 5, or you could just write 0.8 there as well. And let me see, I got to see if we're in degrees. Okay, we're in degrees, so we're gonna find this in degrees, and it is 53.13. Close to 60, not quite, but a good guess. So look at this. This angle is exactly 53. Notice, excuse me. I got to talk a little bit quieter here. Sorry, I'm starting to strain my voice here. So notice that we were only given a point that was on the terminal arm here. We're only given a point. So we were able to find the exact angle by only be giving a point. And that's really important. Okay? Why is that really important? Well, let's just think about this for one quick second. Let's say that you traveled from school 3 blocks east and 4 blocks north, okay, to get to your friend's house. And for some reason, you wanted to know from the school where you left, the corner of the block or whatever, you wanted to know exactly where your friend's house was. You say, I think it's kind of there, or maybe it's over there, maybe it's here. I'm not really sure. I'd like to know exactly where my friend's house is. 3 blocks, 4 blocks. Well, what you could do is you could do a little bit of trig, and you could do a little bit of sin to the negative 1, or sine to the negative 1, a little bit of inverse sine, arc sine. No, not sin minus 1. Don't say that. Don't say that. You could do that, and you could find out, hey, it's exactly 53 degrees, okay? So you could go, hey, I'm going to go 53 degrees. I'm going to use a little clinometer, or I'm going to use my little protractor, and there it is. My friend's house would be right over there. So you could launch a potato gun if you want and see if you can hit your friend's roof. And you know exactly where to go. Okay? You get it? That makes sense? Or you could have your friend climb up on the roof and jump up and down and wave. But he or she might fall off. That's not good. Okay, so that's sort of something you could use that for. Now, here's the thing, guys. Here's the thing. Now, what's important with this is reference angles. Notice this, and I kind of alluded to this before, but I will show you this again. We're going to talk about something called the cast rule, and the cast rule is going to be important in helping us identify the exact angle that's represented, because watch this. If I have an angle like this, okay, and here's the point, watch this. The point, let's say this point is negative 4, 3, okay, close to the other one, but it's negative 4, positive 3. So do you notice, this is very important, so listen up, guys, that this is negative 4, or 4 for a distance on the x, and this is 3 for a distance on the y. So this is related to this angle, not to this one. So when we do this, we're actually finding values for the reference angle. So that's why reference angles are so important. But the sine, cosine, and tangent values for this theta, q, for theta 1, is actually related to theta of the reference angle, to those trig functions. So we're actually finding values for the reference angle. All right. And this one, of course, too, if I do sine, because I know this is 5, right? Sine of theta, that's this big theta, is going to be, we look at this point, and it's opposite, or y over r. Sine of theta is 3/5. But is it positive or negative or what? Well, if you have these exact values and you have this one as a negative, you can use those exact values in your calculation. So for example, x over r is negative 4 over 5. You see that? So the cosine of this big angle is actually negative. Now how do we remember all that? The cast rule helps us to remember. So let's say we are told that the angle is in the second quadrant. So here's let me just erase some of the stuff for you. Oops. Eraser. Okay. All right. So we're told that the angle is in the second quadrant. Here's first quadrant. Here's second quadrant. Third and fourth. And so we know that, and I had this up here before, the sine is positive, but the cosine and tangent would be negative. And we could do that if we actually used these values and Sir Coxer ticks and did that. But you don't have to actually go that far to know the signs for the trig functions. The cast rule looks like this. Start down here, C, and then go counterclockwise, A, S, and T. And what this does is it helps you remember which trig functions are positive in which quadrants. So, the cosine is positive in quadrant 4. All are positive in quadrant 1. The sine is positive in quadrant 2, and the tan is positive in quadrant 3. Okay? So that means that all of the other ones are negative. All of the other ones are negative, and all of the other ones are negative. And in quadrant 1, they're always all positive. Okay, so all this leading up to doing some examples. So there's the cast rule. And, it's cast is the word that it spells if you start down here, C-A-S-T. You might see it as the ASTC rule, which not as nice to say. But anyways, I'm going to quickly move on to a couple examples, because I've been talking for a long time already. But example 1 in your textbook, and you can go there if you want. I'm going to grab my textbook too. So example 1 on page 91. Okay, write trigonometric ratios for angles in any quadrant. Okay, boys, follow along, please. No talking. All right, the point negative 815 lies on the terminal arm of an angle, theta, in standard position. So negative 815 is going to be somewhere around here. So we're looking, this is the angle that we're talking about. This one, right here. That's theta. So we know it's in the second quadrant, right? Determine the exact trig ratios for sine, cos, and tangent of theta. All right. So this is what we do. We know that we have a right triangle here that looks something like this. This is negative 8, and this is positive 15. So we're going to use Pythagoras' theorem to find out what the r is, because we don't know what this is, right? So that's the first step. You don't have to use the negatives here. It's getting squared anyway, so it doesn't really matter. So this is going to be 64, that's 8 squared, plus 225, that's 15 squared, equals c squared. So what's that? 289 is c squared, and that should be about 17, I think. 17. I should probably look this up. Yeah, 17. So this is equal to 17 over here. So this is super easy now. Sir Coxertix. You guys love that, don't you? Sine of theta, and of course that would be this theta, right? It's actually this theta. But we're using these values. Sine is y, that's 15, over r, 17. There you go. That's the ratio. Okay? That's the ratio for sine. Cosine is x over r, so that's negative 8 over 17. And tan of theta is y over x. That's 15 over negative 8. Okay? A couple little things you want to remember here too, and this is just math stuff you might want to remember, that the sine and the cosine always should have an absolute value less than 1. So sometimes they'll be positive or negative, but they always have to be less than 1, like point something. They can't ever be 1 point something or 2 or 3 point something. Sine and cos can never be. But tangent can be. Yeah, tangent is greater than 1 lots. Okay? So just if you've got something greater than 1 for a sine ratio, you better look again because something's wrong. Okay? All right. Now, I've used the exact values here, but the cast rule, right, says that only sine should be positive in this quadrant. The sine is positive, the cosine and the tangent are both negative, so we're good to go. Okay? So that would be the answer, and you can leave them in fraction form. I think those should be your answers right there. Okay? Any questions on example 1? Okay, just that's the main thing that we've learned here so far. Okay, example 2 says this. Determine the exact value of cos of 135. The exact value, cos 135. Okay, so what does exact value mean again? That means we can't have decimals. We can't round a decimal. We need to have a fraction answer or a radical in the answer, right? Okay, so let's take a look at it this way then. This is 135 right here. What's the reference angle for 135? What's the reference angle? 45, thank you. 45 is the reference angle. So guess what? The 45, 45, 90 triangle. You guys remember that one? 1, 1. And what's over here on the hypotenuse? Ooh, anybody? Got to have that memorized. That's root 2. 1, 1, root 2. Okay? So from 2.1, which we did a few days ago, last week I guess, the end of last week, you got to memorize those special triangles. Okay? Got to do it. 1, 1, root 2. So remember, the reference angle for any angle, you can look at the values for that reference angle, and they'll be related to the trig values for the larger angle. You just have to make sure the signs line up, the positive or negative. So if we take a look at 45, the sine of 45 here is what? Opposite over hypotenuse. That's 1 over root 2. The cos for 45, because it's a reference angle, I can work with that one. The cos is what? Adjacent over hypotenuse, or x over r. Right? So that's also 1 over root 2. And the tangent of 45 is 1. 1 over 1. Okay? Sir Cox or Tix. SOHCAHTOA. Same thing. Now, the cast rule says C-A-S-T. So in this quadrant, only the sign is positive. So when we go sine of 135, it's the positive version of what it is for sine of 45, which is the same. There's the sine. The cosine of 135, we refer to the cosine of 45, and I have to make it negative. Negative 1 over root 2. And the tan of 135 is the same as tan of 45, which is 1, but I have to make that negative as well. Now, I guess this one just asked for cos, I guess, right? I just did all three for you, but there's the one that it asked for. Okay, is this kind of lining up? If you're struggling right now to put this all together, it just means that you need to spend some time on your own with it. In a quiet place with no distractions, you need to read through this, watch the video again, do some extra homework, look at the examples again. You just need to kind of process it. You'll figure it out once you go back to it, okay? But if it's kind of like bouncing around in your head right now and you can't pinpoint, can't make these connections yet, you just need to spend some more time with it, okay? On that note, I think I've got just one, there's two examples, so what are we at for time? We're good for time. It's a bit of a longer lesson today. Example 4, okay? Example 4, determine trig ratios of quadrantal angles. So a quadrantal angle is an angle in standard position whose terminal arm lies on one of the axes. So we're talking about 0 degrees, 90 degrees, 180, 270, 360, and then the like, okay? So in the first 360 degrees, those are the angles we're talking about, all right? So what I'm going to do is I'm going to just explain really quickly how you would find these out. So watch this. If I had an angle like this, and I wanted to do sine, let's say, sine, it's always y over r, right? Sir, S-Y-R. So here's y, and here's r, okay? Well, what if I do a different angle that's getting closer to 90? Okay, here's my other angle. Here's y, and here's r. Notice that x is getting what? Smaller and smaller as we move towards 90. So at 90, you can think about it this way. The y value and the r value are exactly the same. So y equals r. And what is x? X is 0. Y equals r at 90. Because remember, that terminal arm is going up like this, and here's y, and here's r, but when it gets to 90, they're both the same length. So y equals r and x equals 0. So we have y over r. So what is sine of 90? Well, it's y equals r. So something divided by itself is 1. Sine of 90 is 1. Okay? In pre-calculus 30, this gets even easier to remember. Just not sure I want to launch into the unit circle with you. I don't think so. Not going to do that today. So sine of 90 is 1. Let's just go cos of 90 now. Cos of 90. Okay. So let's say for argument's sake that this is a value of 1 up here. Cos of 90 is, that's c equals x over r, right? So x is what? 0. So 0 over anything, any value is 0. So cos of 90 is 0. Tan of 90, well, the t is tyx, right? So it's y over, and x is 0. So this is a problem. This is like 1, let's say it's 1 over 0. What's 1 divided by 0? Is it 1? Is it 0 or something else? It's something else, right? What is that something else? What do we call that? What's the answer for that? What would we say? It is error, okay? Your calculator will say error, yeah. We say it's undefined, okay? We say it's undefined. So does not exist or undefined would be the proper way to say that, okay? So tan of 90 is undefined. Okay. Now, all right, so I'm just going to clip this out of the textbook here for you. This should help you, okay? So we have the point here on this terminal arm would be the point 0, comma, y, and r equals y. So x is 0, r equals y. That's what I mentioned there before. For the other ones, okay, so let's say sine of 180. What's sine of 180? Well, sine, sir, S-Y-R. So y, here's y, over r. R is x. So 0 over x, that's 0. So sine of 180 is 0. That's how you figure that out. What's the cos of 180? Well, cos of 180, that's x over r. So x is this, and r is the same as x. Well, we got negative x over itself. So that's going to be negative 1. Okay? So negative x over r. Negative x over itself. The positive version of itself. R is always positive. R is always positive, right? And then tan of 180. And yes, you can do this on your calculator if this really is confusing, I guess. The tan of 180, right? T y over x. So again, y. Did I get that right, sir? Yeah, y over x is 0 over x is 0. All right? 0, negative 1, and 0. Yeah. Yeah. Okay. All right. I'm going to skip number 5. It's in your textbook. I won't go through it with you right now, but you can look at number 5. I might come back to it. Here are the key ideas. Please take a moment to look at the key ideas. If there's anything in there that you don't understand or you think I haven't covered, let me know. Okay, there's your assignment for 2.2 for this time around.